Hi everyone, today we'll discuss one more problem on sequences and series. Test for the convergence of the series summation n equal to 1 to infinity minus 1 to the power of n square root of n plus 1 minus root n. This series we have to go for the convergence of the series or divergence. We don't know. First un term. What is un? Un equal to minus 1 to the power of n plus 1 minus root n. You see, un is there, minus 1 to the power of n is there. We have to apply the mod. We have to apply to the mod to the given series. Why? Because we have definition for any test. If you want to apply sigma un is a positive term series, then the test will come, all the test for the positive term series. Only one test is there for alternating series, that is Leibniz test. Okay. So we are applying the I want to apply the limit comparison test. For that, the series should be positive term series. So therefore, mod of un equal to square root of n plus 1 minus n is there. Now, this is a particular type of the problem where we have to rationalize the numerator. Generally, we rationalize the denominator. What is rationalization? Root n plus 1 minus root n. Whatever is there, you have to write the same thing in the numerator and denominator. If minus sign is there, you have to write plus sign. Now, denominator, this is by 1. 1 into anything is that thing only. So, n plus 1 plus root n. This is a minus b, a plus b. A minus b, a plus b. A minus b, a plus b means a square minus b square. So, therefore, this is n plus 1 whole square minus root n whole square. So, what is that? Now, root the power get cancelled, root the power get cancelled. So, we are left with n plus 1 minus n. By this, we have, if we take n common, root of 1 plus 1 by n plus 1. If we are taking root n common, getting cancels. So, we are left with 1 by n to the power of half into 1 plus 1 by n plus 1 mod of un. Mod of un. Okay. Now let vn equal to 1 by n to the power of 1 by 2. That means summation mod of vn equal to summation 1 by n to the power of. This comparing with p series. Comparing mod of vn with p series. What is p series? Summation 1 by n to the power of p. What it says? P is less than or 1 equal to 1 divergent. P is greater than 1 convergent. So here, if we are comparing with the p series, n to the power of half. Comparing with the C series, P equal to half. Half means less than 1. Less than means divergent. How can you say? By P series. Keep aside. This is for time being. Keep aside. Now, mod of un by mod of Pn is how much? Mod of Pn is 1 by n to the power of half. Mod of un is 1 by n to the power of half into 1 plus 1 by n plus 1. Now apply the limit. Limit n tends to infinity. This is 1 by n get cancels as n tends to infinity. 1 by n tends to 0. So therefore root of 1 is 1. 1 plus 1 is 1 by 2. 1 by 2 is not equal to 0, which is finite and non-zero. It is finite and non-zero. By comparison test, mod of un and mod of vn both converges or diverges together. Therefore, summation of mod of un is what? Here, by p series, it is divergent. So, one part of the series is divergent. After applying the limit, mod of un by vn is also, so this is also divergent. Therefore, mod of un is divergent. How can you say? By limit comparison test or simply comparison test. So what we have done here plus C here. This is a problem, a special type of the problem where we are rationalizing the numerator, first thing. Second, we are applying the mod. Why we are applying the mod? To make the series as a positive term series. Why we want to make the positive term series? Because we don't have any test for alternating series. We were only Leibniz test is there, and it is only for monotonically decreasing alternating series, then monotonic. It is monotonically increasing series maybe. So we are applying first rationalization, then to apply the limit comparison test, we have to take one part of the series, we call it Vn, then we'll compare with the whatever the series we can compare P series or GP series, whatever. Accordingly, we got some result. Keep the result aside. Then limit n tends to infinity un by vn. Applying, if it is finite and non-zero, then whatever the result we got by the part taken part of the series, that we are using that. So divergent here. Therefore, a limit comparison test is by comparison test, both they can converge and diverge together. So by comparison test, summation un and vn both converges or diverges together. Therefore, sigma mod of un is divergent by limit comparison test or simply comparison test. Thanks for watching. Please do subscribe my channel and share with your friends. Please do so.